Hi, hello all. I am Shekhar, a MTech first year student at Department of Electrical Engineering, IIT Tirupati, and is here to present a paper titled The Recognition of Human Movement Using Temporal Template as a part of Computer Vision course. Coming to the details of this IEEE paper, this paper titled The Recognition of Human Movement Using Temporal Templates was published by Aaron F. Bobbick and James W. Davis in March 2001 at IEEE Transactions on Pattern Analysis and Machine Intelligence. It has about 1704 paper citations. Coming to the problem definition, as defined in this paper, the main aim is to represent and recognize human movement by view-based approach. The process is as follows. Basis on the representation is a temporal template. Temporal template is a static vector image which is used to represent the movement of a subject in the given image, and the recognition is done by matching against the stored temporal templates. Here are some of the images present as frames of a sequence. These frames, frame 5, 25 and 40 are of less resolution. One cannot recognize what is the movement in a subject by just looking at static process of these images in a sequence. But if they are put in motion, one can easily recognize the movement present in the sequence. Coming to the pre-work of this paper, it can be divided into three categories. One is generic human model recovery, the second one is appearance-based models, and the third one is motion-based recognition. In generic human model recovery, the three-dimensional model of an object can be reconstructed from the given image. For this three-dimensional reconstruction, it requires strong segmentation of foreground or background. But due to the self-occlusions that frequently occur in recording an image, it may lead to major limitation of three-dimensional reconstruction of an object and then further recovering or recognition of human movement. And the next one, second one is appearance-based models. In these appearance-based models, action is described by sequence of two-dimensional poses of an object. By observing the two-dimensional poses of an object of subsequent frames, one can define what is the human movement or what is the movement of a particular object. For this recognition of a movement, individual features or properties are extracted and they can be tracked from each frame in an image sequence. Unlike the previous two, the third one is motion-based recognition. In motion-based recognition, the main aim is to directly recognize the motion itself without observing the static poses of the object from the previous frames. In this, the analysis is done like recognizing the body region as a single blob-like entity and then tracking the predefined regions like legs, hands, and mouth and defining the movement of a human in motion-based recognition. Now coming to the temporal templates. These temporal templates are the basis in representation of the human movement and further help in the recognition of this human movement. What is a temporal template? Temporal template is nothing but a static vector image where the vector value at each point is a function of motion properties at corresponding spatial location in an image sequence. This temporal template consists of motion energy images and motion history images. These motion energy images usually define where the movement is in the image pixel region. Consider here I of x comma y comma t as the image at tth instant and x comma y correspond to the spatial location of that image region. And the binary image sequence can be generated, that is d of x comma y comma t, by usually subtracting the image at this instant and the previous instant, that is image differencing. And it usually easily defines where the movement is present in an image. And then generating the motion energy images, the energy at particular location x comma y and that particular instant t can be generated by union of all such binary image sequences uh, up to a time tau. This tau is nothing but uh, the time duration of a movement. It can vary from one to the other. And the next one is motion history images. Unlike the motion energy images, motion history images usually defines how the movement is in an image. This is defined as h tau of x comma y comma t at spatial location x comma y and the time instant t is tau, that is duration of the movement if that a binary image sequence is 1, or else maximum of 0 comma h tau of x comma y comma t minus 1 otherwise. Here are some of the images, motion energy images that can be observed here from the given frame images. And similarly, for a sit down image, how the motion history images looks is also represented here. Now coming how the recognition system of this human movement works. The first step is to collect all the training samples of each movement from different viewing angles. And then from these different viewing angles, after collecting all the training examples, we generate motion energy images and motion history images of all such examples. By generating these motion history images and history images and motion energy images, we compute some features such as 7HU movement based features. From these 7HU movement based features, we generate a statistical model of each view and each movement, generating mean vector and covariance matrix of motion energy images and motion history images that are built from previous examples. If a new input movement x is given, now a Mahalanobis distance is calculated with all these statistical models generated, and the closest movement is recognized based on the least movement corresponding view of a corresponding movement is considered. This is how the recognition system works here. Now, testing this recognition system on aerobics data. Here, 18 aerobic exercises were considered that are performed by an aerobics instructor and these aerobic exercises were captured in different viewing angles from plus 90 to minus 90 degrees in 30 degrees increments in a horizontal plane. After recording these 18 aerobic exercises in different views, motion energy images and motion history images are calculated. The motion energy images of all these 18 aerobic exercises are represented here in the given figure. Why do we need both the motion energy images and motion history images? Usually, motion energy images can be generated from motion history images itself by appropriate threshold. Then why do we need both? The answer is here. Consider here move 4 and move 17. The motion energy images of this move 4 and move 17. They look approximately similar, but their motion history images are distinct. This helps in good recognition of the movement. Similarly, for move 2 and move 4, they have similar motion history images, but motion energy images are distinct. This helps in good recognition of the movement and resulting in less errors in the appropriate recognition of the particular movement. Some of the results observed here by using 30 degrees of frontal one camera. Here 18 test aerobic exercises were performed and the closest distance is calculated by Mahalanobis distance, and the closest move is recognized and the corresponding correct match with the correct distance is represented here, and the median distance when all the distances are placed in ascending order and the corresponding rank of the correct distance is also given here. Observing all these statistics, one can easily recognize that out of 18 aerobic exercises, 12 aerobic exercises were correctly recognized, and the remaining 6 aerobic exercises were misrecognized. Of these 6 aerobic misrecognized exercises, they do not much deviate from the correct match as well. And here are some of the examples where the error is occurred. Here A is test input of move 13 at 30 degrees of frontal camera, and B is the closest match obtained by Mahalanobis distance, that is move 6 at 0 degrees angle, and the correct match motion history image is also given here. All these motion history images, comparing with the test movement, the motion history image of move 6 at 0 degrees is almost similar, and hence it may lead to misrecognition. The errors in the previous using one camera can be nullified or can be reduced using two cameras in the subsequent testing. By using two cameras, the results obtained are as follows. By observing all the statistics, it can be easily recognized that 15 out of 18 aerobic exercises are correctly classified and the rest are misclassified or misrecognized, and these misrecognized human movements do not also much deviate from the original closest or original correct match. Examples of the where the error is obtained is also given here. Consider A as a test input of move 16 and B as closest move, which is 15 obtained by Molyneux test, and C is the correct match. Here, why does this error occur? Here, in our training examples, we considered only one aerobic instructor in generating a statistical model of all motion energy images and motion history images. Due to this, a less covariance may exist, and the test subject may perform more movement or less movement uh, comparing with that aerobics instructor, and hence this error may occur. By considering many aerobic instructors examples in generating statistical model, this error can also be nullified. Now coming to the conclusion, where an application we discuss. One of the applications discussed here is the kids room, an interactive play space for children. In this interactive play space for children, the basic idea is that the children were placed in a room where it has a maximum of 4 children. Uh, the room is aware of the children and takes them through a story where the response of the room are affected by what the children do. That is, by recognizing the movement of the children or recognizing the actions of the movement, the corresponding responses are given by the room, where the room consists of all videos, sounds, and lights. For example, if a monsters appear on the videos and tell the children to dance, and if they dance appropriately, then the corresponding sounds or lights may uh, take place in the room, which gives a good play space for children. This is one of the application for good recognition of the movement. The subject is subtracted from the background and correspondingly motion energy images and motion history images which lead to temporal template, and then further recognition of the movement is done here. This is one of the application of this recognition of movement using temporal templates, which leads to the real-time application and is of not much computational complexity. This is about the paper presentation on the human movement recognition using temporal templates. Thank you.